welcome to this new episode of our podcast. I'm Marnix Jr., President of the Civil Engineering Club here in Cyprus International University. And today I'm having as guest Assistant Professor Mehrnoush Kohandel.
Yes, hello everyone, and thank you for the correct pronunciation of my name. It's a difficult name, I can understand that. As you said, my name is Mehrnoush, and I'm here as a water engineer mostly, which in fact is a branch of civil engineering. And I started my studies back in my country, in Iran, and after my graduation from my bachelor studies, I started my master's in hydraulic structures. And while I was doing my master's, I started working as a water expert in a civil engineering, consulting civil engineering firm, which its focus was mostly on designing channels or repairing some old dams and water resources, things related to this. And after that, I started my PhD in Turkey, in Istanbul Technical University, and which was again focused on mostly hydraulics and sediment transport and things like that. And then I had a chance to have a 1.5 year of a postdoc study, research year for about 1.5 years in Izmir. And then I came here, and now I'm here.
Thank you for that brief, let's say, summary of your
You're welcome.
of your resume actually. Thank you.
You're welcome.
So I want us to talk about fluid mechanics or hydromechanics. Actually, it's a course, or there are courses that kind of nightmares for many students.
Oh, come on.
Okay, in quotes.
Yeah, I know.
Quotes. So, what's fluid mechanics or hydromechanics actually? Because if you ask me, I would say fluid mechanics is the study of fluid. I mean, is when at rest and in motion. But is that definition actually sufficient? Are there some more details?
Yeah, actually, when I ask my civil engineer colleagues or friends, they usually say, when they know about my branch and my expertise, they say, oh, I always hated that fluid mechanics, and I always hated that hydromechanics. In fact, as you said, it's true. Most people may don't like it, because when you say civil engineering, most people think like building structures or buildings, apartments, villas, things like that, focusing about maybe the ground, the soil, the building structure, and so on and so on. So it's not very, common for people to know that in fact in civil engineering there is a branch called hydraulic structures, or water resources studies, or even hydrology and things like this kind of fields. So fluid mechanics and hydromechanics, mostly, so fluid mechanics is giving you a fundamental and base for your future studies if you're going to have to get expertise and to specialize in water structures, hydraulic structures. So it's talking about the behavior of the first. You learn about what is fluid and the behavior of fluids, mostly water, in contact with the structures, in like dams, like reservoirs, like channels. So you're learning the principles and laws that we have related to the fluids in contact with the structures.
So, what about hydro? Can we talk of fluid mechanics and hydromechanics are the same thing?
No, fluid mechanics. So when we say fluid mechanics, it's a general field. In fluid mechanics, you have your fluid as water, as oil, even the blood in our bodies is kind of a fluid. So you're learning about a general principle about the fluids. Okay, so someone who is a biomedical engineering may also need to learn about fluid mechanics. A mechanical engineering field also needs to learn about fluid mechanics, because they are going to deal with the fluid as, for example, oil or water in a pipe flow system network, or when they want to choose a correct and right pump for their system, they need to learn about that. So environmental engineering also need to learn about fluid mechanics. Petroleum engineering also need to learn about fluid mechanics, because they are going to deal with oil, and oil is a fluid. So fluid mechanics is generally dealing with fluids, but in hydromechanics we're usually mostly dealing with water as our fluid, right? That's but usually the fluid mechanics is the base of hydromechanics.
Okay. So as a fluid, we can also talk about air.
Of course, yes.
Okay.
Yes, aerodynamics also, it was a good example, thank you. So aerodynamic engineering also need to learn about fluid mechanics, because they are going to design and think about the best structure of, for example, airfoils or the planes, which is dealing with the air around that, and air is a fluid.
Okay. So is that, or are those courses actually important, like really important for us civil engineers? Are they really important?
Yes, of course. Of course, it depends on your specialization.
Okay.
If in future you're going to focus on, for example, structure and geotechnical studies, or if you're going to focus on transportation engineering, you're not very much going to need a very deep understanding of these two courses. But if you're going to study and work in the subject of hydraulic structures, like designing the structures, like as I said, the channels, open channels, pipe system that is used for transferring water, or I don't know, other fluids from one place to another, these kind of things you absolutely need to learn about these two courses.
Okay. And for example, for someone who is working inside, an engineer working inside, does he really need an understanding or a strong understanding of fluid mechanics or hydromechanics to work inside?
As I said, if you're working on site and you're dealing with building structure and apartment structure, of course you don't need to have a deep understanding of fluid mechanics, because you're working with some other you're working on some other studies, right? But if you are working as a coastal engineering or coastal engineer, river engineer, someone who his or her expertise is in structures related to water, then absolutely you will need this two courses.
So in road construction, for example, you don't have to take into account such aspects.
It's not directly, of course, related, but I always believe that anything that we learn in during our studies is like a exercise for our brain. So it's good to use different parts of our brains during your life. So it will make your brain like your body. If you don't use some muscles of your body, that will be weak and you will have problem later. So brain also needs practice. So as much as you practice on different fields and think and try to analyze different things, you will have a stronger brain for your other analysis. Maybe it's not directly related, but indirectly it will absolutely be very useful.
So since we don't really need, if you want to go into structural engineering or transport engineering or construction management, you don't really need these courses. Why do we put it in undergraduate? Why don't they put it in masters, for example, for specialization?
Okay, that's what you do and what you study in your bachelor. So in your bachelor, it's valid for all other fields as well. We have different fields, different courses, and we give a basic information to the students, and we let them to choose among them. So when you're a bachelor student of civil engineering, you don't know yet that you're going to study transportation,
Yes.
or I don't know, geophysical studies or structural studies, right? As well as hydraulic structures. So while you have transportation course something related to transportation in your bachelor, of course you will have something related to water and hydraulic studies in your bachelor, so that you will get some basic information and decide which field you are going to continue and which field you are going to have expertise in future.
So, are there like challenges someone or an engineer might face in applying those principles or theories of fluid mechanics in the field?
Of course. So fluid mechanics and these two basic courses, in fact, as I said, are fundamentals that help us to study in the future about water resources, about the behavior of the water. And in fact, we are dealing, in the future, we are going to deal with nature, with some part of the nature. You are going to study water in a river, for example. We are going to study water in a river, and then you're going to build a bridge in that river, right? So you're facing with some unpredictable events. You may face with some unpredictable events, like for example floods that may happen. In other term, because nature is by itself very complex, formulating everything that happens in nature is really difficult. And in hydromechanics and fluid mechanics, we are just doing that by doing experiments, by doing some empirical studies. We try to formulate the behavior of the water or the behavior of other fluids. So we cannot make sure that the fluid that we have formulated that is always going to follow these theoretical studies that we have. So that's why there are so many studies done, experiments done, and empirical studies are done to try to make sure that we are doing right, we are following exactly how the nature behaves. So that's why it makes it really difficult. And we are going to model, in fact, in our studies, we are going to model the nature. So there are some modeling, numerical modeling programs also that hydraulics engineers and water engineers will do. So we do modeling of the nature, but we are not 100% sure that the nature will behave as we do. So we do again study the nature and try to model again and try to make our model as close as the behavior that there is going to happen in the nature. So we are facing with a complex nature, and we are going to make our theoretical studies close to that nature. And as I mentioned, we are going to face with some unpredictable events that even though we study a long data of the history that we have about the water level in the rivers, the precipitation, and so on and so on, we may not be 100% be able to predict when a flood going to happen, you know. So this is really very exciting, but unpredictable and difficult to predict field of study.
So you already said that for things like structural engineering, we don't really need such ideas, but is there, I mean, since we don't need it, is there a possibility for a project to fail because of a wrong understanding or wrong application of fluid mechanics or hydromechanics principle?
Of course, if you're in civil engineering trying to build a structure which is related to, for example, a water structure, a hydraulic structure, like a dam, like an open channel, if you don't have enough information about, for example, the rise of the water due to precipitation, right, then you may not correctly design the height of the dam, for example, according to the level of the water, because there may be some rise in the water and there will be some overtopping from the dam. and that will endanger the life of the dam. Or if you're going to build an open channel without consulting with the hydraulic structure engineer or hydraulic engineers, let's say, in that case, again, you will need to design your open channel in a way that nothing happens, no problem will occur about the rises of the water inside the channel. So there should be a freeboard, for example, designed in an open channel. So hydraulic structure engineers or water engineers should work along with the civil engineers who are trying to design that structure.
Okay. And is there a crucial field for civil engineers where we have to, actually we must have a good basic or a strong knowledge of fluid mechanics? Is there such a crucial field for civil engineers?
Again, if you're going to specialize in this field, you have to have a good knowledge of these courses. And of course, these two courses are absolutely not enough. So you need to have a good information and good knowledge related to water resources as well. So you need to have good knowledge related to hydrology as well. And to answer your question, so you know that in recent years, we are dealing, for example, with climate change and drought problems. So these, it may be a surprise for you, but these are also branches of civil engineering. So in your master or in your PhD, if you focus and try to learn more detailed information about hydrology, about water resources, you are in fact trying to have some solutions for the drought and for climate change. So this, the basic information that you learn in your bachelor years, and you complete your knowledge by having more detail, getting more detailed knowledge by studying hydrology and water resources, is really important for this kind of, in these fields, like studying about climate change, studying about drought and so on. Also, you know, for example, if you don't have a good understanding of the behavior of water, you will have problem in design of a bridge. There will be erosion. You know that erosion is something inevitable when we are facing, when we are having a structure in a river, for example. That the life of that bridge should be safe for a long time by predicting how much erosion is going to happen around the legs of that bridge. So you need to have a good understanding of the behavior of the water, behavior of the fluid that is going to reach to that bridge before structuring that bridge. So in all these fields, you need to have a deep understanding of fluid mechanics.
So in the case of the bridge, for example, who is, okay, for the design of those legs, who is in charge of that? Is it the structural engineer only, or the hydraulic engineer, or both of them?
Both of them. So there is a viewpoint that, you know, what I want to say, we shouldn't be selfish when we are doing projects. We shouldn't believe that I am the best and the knowledge that I have is the best. It's the terrible thing that someone may have in his or her working life, right? So if your expertise is some special field, you need to ask for help from other people, and you have to learn to cooperate to make a good project at the end when you do something like that. So, for example, hydraulic engineers do research about the optimum shape of the bridge legs, right? And provide these results of their research in different papers and so on and so on. And then structural engineering will use this information for the design of their structures.
And for example, for someone, a student, let's say a bachelor student, who is interested in learning more about the behavior of such Fritz in hydromechanics as well.
Mhm.
Where can he get knowledge? I mean, apart from the classes, where can he train himself to acquire more experience in those areas?
So I always recommend students to refer to books. Of course, recently there are lots of, the way of teaching and learning has changed. So there are lots of online references that the students can use. You can use those references as well, but as a correct information and knowledge, if we want to get, I always recommend students to refer the books and the references that are available about these topics. But as I said, there are platforms that provide information about water management, I don't know, water transfer, or structures, hydraulic structures, water engineering, this kind of. There are lots of platforms. I'm sure you know about them, right? So they can use these books. But the best way, if you want to expert this, maybe someone who is interested in the topics can continue his or her studies in master. In that way, you have a chance to get more information about the things that you're interested in, and also work if you choose to work in this field, doing project or getting involved in projects that are dealing with these kind of problems will be a really good jump for your level in your knowledge.
So, do you have have you ever experienced such a situation where the failure to understand fluid mechanics or hydromechanics led to a disastrous situation in a project, or have you experienced something that you have to relate to?
Well, I myself haven't experienced that in close relation with this kind of problems, but we can find lots of examples in the news about this kind of failure of the structures that are related to hydraulic structures. Like, for example, the dams that they have problem and they cannot stand the, for example, the forces that is buried on them. They cannot stand. We've experienced the collapse of the dam, or the collapse of the bridge because of the erosion. There are lots and lots of examples about this kind of bridge, especially bridge collapse due to the erosion. That's why it's one of the commonly researched topics, the erosion around the legs of a bridge, because it's really it make problems, right? When there is an erosion and the bridge collapse. So this is because of the lack of study, a good study about the level of the erosion that will occur during the time when you do the design of that, for example, the bridge.
Well, thank you for this clarification. So actually,
Will be able to learn and study and work about the coastal protection, river protection, I don't know, flood control, designing about the channels when you want to transfer water for irrigation from a region which has enough water to a region to fields, to farm fields that need water. These are all a branch of civil engineering, and please don't underestimate these two important courses.
thank you, brother. Thank you.
You're welcome.
Are there any other things you want to say concerning the topic that maybe we didn't discuss?
Yeah, just as I mentioned, these two courses even are not enough to introduce what water engineering will do. They are not enough, so we need more courses like the hydrology, like water resources, like sustainability in water resources. These are all courses that give you an idea about the general idea about the water and the field of hydraulic engineering and water engineering, and it will help you to decide about what field you're going to study. So if you don't have these two courses or more courses about this, we will get the chance from the students to choose
Okay.
in their
Yeah,
future.
see, actually, we are putting them in front of the many routes. They have to choose
Yes.
what is fitting.
Exactly.
That's a good idea, but for some,
Come
it's not
on.
very easy. uh, so, guys, thank you for listening. I hope you enjoyed this exchange and you understood that fluid mechanics and hydromechanics is a very important course.
Yeah, I mean you can choose, right? Don't underestimate.
Yeah, that's it. So, see you next week in another episode.